Good afternoon, this is Dr. Pearce from Cotswold School and I am going to be answering question 7 from the 2023 AQA GCSE chemistry paper. So the first one is completing the half equation for the reaction occurring at the negative electrode, and I can see it's Al3 plus number of electrons goes to Al. We can look at that as Al0 because it's elemental aluminium, which means it has an oxidation state of 0. So in order to make that happen, I have to add 3 negative electrons to the positive 3 plus. And that makes 0. So it's Al3 plus 3 electrons goes to aluminium. So cryolite contains Na plus ions as well as Al3 plus ions. Just one reason why sodium is not a product of electrolysis. Now, if we look back into our solution electrolysis, so aqueous solution electrolysis, we know that anything that is more reactive than hydrogen doesn't get discharged. The hydrogen gets discharged. So in this case, we can see that sodium is pretty reactive and aluminium is less reactive. So we get the same sort of effect. So one reason is that sodium is more reactive than aluminium. So very, very similar to what you've learned about solutions. A student investigated the electrolysis of an aqueous solution of a different compound, and there's a lovely diagram of it. And we can see what we've got is some test tubes which are balanced on the beaker. They've been filled up so that they collect the gas quite nicely. Hydrogen was produced at the negative electrode and oxygen was produced at the positive electrode. Explain how... actually, I think we might have missed something. No, we haven't. That was a different question I was thinking of. Hydrogen was produced at the negative electrode and oxygen was produced at the positive electrode. Explain how oxygen was produced from water during the electrolysis of this aqueous solution. So let's talk about it. During electrolysis, of an aqueous solution, basically water gets split up as well. So water splits into H plus OH minus. The OH minus is attracted to the positive anode, negatives cathode. So anode so what happens is a reaction takes place there. And that is 4OH minus becomes O2 plus 2H2O plus 4E minus. So this is going to be your oxygen gas coming off. Student compared the volumes of 2 gases collected. This is the question I was thinking of earlier. How can the student change the apparatus in figure 7 to compare the volumes of the 2 gases produced more accurately? So we go back and we look at this and we go, okay, this is in test tubes. Now, if you're analysing the volume of the gas, you're not going to be able to do that very accurately here. We do not have any measurements. So what I'm going to say is to replace the test tubes with measuring cylinders. Now, it doesn't necessarily have to be measuring cylinders. It could also be a burette. It could also be a gas syringe. And the reason for it is because the graduations, which are the little things with the numbers on, will allow us to tell exactly how much is in there. So it'll allow you to accurately read the gas volume. So the overall equation for the reaction is 2H2O goes to 2H2 plus O2. What volume of oxygen is produced when 20 centimetres cubed of hydrogen is produced? I can see that in here we've got 2 molecules of hydrogen are produced and 1 molecule of oxygen is produced. So if I have 20 molecules of hydrogen, I'm going to make 10 molecules of oxygen. If I make 20 centimetres cubed of hydrogen, we remember each gas has the same volume. If we have a mole of it, we are going to make 10 centimetres cubed of 10 centimetres cubed of oxygen. Okay? And that is question 7.